Welcome back to the 27. After this last weekend's racing sim tools rundown, I've received a lot of questions with regards to setting proper car parameters in AMS2. As we know, the car parameters are vital for the graphs to function properly within the software. Considering that I glossed over the car parameters a little bit, I thought it would be better to briefly go over how to set car parameters, because I found myself trying to type it out, and although it's a relatively simple process, no matter how I wrote it, it was still confusing. Hence this video. So for some sims, RST has the car parameters preloaded, so there is little, if any, work you need to do here. AMS2 is relatively new, there's more cars, and a lot of the cars are relatively unique, so it's not the case, and we have to plug in some data for the graphs to function properly. For the car parameters, what we're responsible for is the wheelbase, front track, tire diameters, and spring installation ratios. Okay, so here we are in RST. Now there's two ways to input parameters in the software. A good way and then an okay way. The best way is to have the parameters preloaded using the drop down at the top. This means that the game will directly draw and filter all of the data through the parameters as appropriate before you even start driving the car. But say you need to make some changes after you do a session, and this is actually important for setting the car parameters. You look at this icon up here with the little vehicle on it, and here you can see that I've already have all of the default information that I grabbed from the game inputted: gearing, all of the damper information, bump stops. I have the default suspension, the ride heights, ARBs, and also the bump transition speed, which I use 35. I would recommend using 35 or 40 for AMS2. But the question is, all of these ones that we have to put in ourselves in the chassis screen here, it's tire diameters in millimeters, wheelbase in meters, front track, and then spring IRs. How do we go about setting these appropriately? It's actually really simple. So the first thing we're actually going to do is we're going to do some internet research. We pull some of the information just from real life data, from the real life cars. So the wheelbase, front track, tire information, all of these things we're going to grab as a starting point for the cars that we're looking at. We're going to be working with the Sauber C9. So I did some research, found this website here. It's called supercars.net. So scrolling through, a lot of this is just information about the cars, but we're going to be focusing on a couple of things here. We're going to be focusing in on the wheelbase and the front track, 2700 millimeters and 1600 millimeters. Write that down. Next, we're going to be looking at the tires, and I did a little Google research about the tires. The Group C cars used Michelin tires. I did a Michelin Group C tire diameter Google search, and I found this website, sascosports.inc, and it tells us down here that the Group C cars, you can see how they have the tire diameters here: 25.6, 26.8, 28.0, 28.1. Now, which ones do we use? It's not really that necessary. This is just a starting point, and the game uses millimeters, so we'll basically go into a simple inches to millimeters calculator, and then we have the information we need to get started. Alright, so we're back in RST now. You can see that the front wheel slip and rear wheel slip are basically non-existent. So let's start plugging in the numbers and see how the graphs change. So we're going to click this little icon up here. We're going to plug in everything that we learned from the internet, the wonderful internet. 650 tire diameters for both sides, or both ends, it doesn't matter. We know the wheelbase is 2.7 now. We know the front track is 1.6 now. Now let's exit out, and there, boom, we have data. The next thing we're going to do is we're going to set the wheel diameter so that the game, the software, I should say, reflects the the proper wheel slip. Anytime that the wheel slip is off of the 0 mark, that means the tire diameter is off. Now, I have to correlate this. The game and most sims in general don't need to program like a tire spinning. So the actual, whether or not the real life tire diameter is reflected in the software or in the game it's kind of inconsequential. So what's most important for us is that the data has the proper starting point. So the figures at the end of the day are not going to be like the real life cars. So just get that out of your mind now. We're going to gimmick this so that the graph shows appropriately. So how we get set about the wheel diameters is we're going to zoom in at a nice straight section. Let's say the Kemmel straight here, when you know the car is pretty stable. And we're going to zoom in really tight here. Zooming in, adjusting the graph, and then we're going to also zoom in on the rears as well. Let's see here. Yeah, that's a good spot right there. At the end of the straight is when the car is probably the most stable. Now you can see if we're looking at it's oscillating. That means there's just minimal slip going down the straight. So the perfection isn't necessarily possible, but we're going to be looking at, this is a good spot right here, and we're going to be looking at adjusting these wheel slips in the parameters themselves so that they change in the game. So it looks like 650 on the front. Let's concentrate on that for now. And it looks like we have a ways to go. The game, the 0 line is up here. So let's start plugging in some numbers here and see how it adjusts the graph. So we're going to do 660. A lot of trial and error here. And did that make it worse or better? Looks like it made it worse. So we go the opposite direction. Let's go 640. All right. Ah, it's closer. We're getting warmer. Let's do 630. Even closer. So you get the idea here. 620 for the fronts. Even closer. I have to move so we're zeroing it in here. I'm going to do 615 next. Up a little bit more. But you get the idea here. Let's do 617. All right, little overshot there, 616. And we're really close. So like you can see that the percentages is really like within 1,000th. Oh, I'm sorry, 100th. So that's really kind of all you really need to do. I think that's perfectly acceptable for the fronts. For the rears, we're going to do the same thing. I think this one goes down, if I remember correctly. Let's see here, 655. Let's try 655 and see how that does it. Yep, we're really close there. That's really within. It's a little bit off, but I'd like to get it within, so it's within the 100th decimal point. So let's do 655.5. We're getting closer. 655.8. Yeah, probably a little bit more. Let's do 56.5. Getting really close now. Let's do 657. Really warm. Let's try 58. I think it might overshoot with this, but that's fine. Nope, that's perfect. Right there. So you can see that the tire diameter. Oh, why did the front go off? Let's see. Let's try this again. No, I'm sorry. That's because I'm zoomed in. I'm zoomed in too much. So now we're looking at like we're going to look at it like as if we were looking at it when we were doing our wheel slip evaluations, and you can see the deviation from the 0 line is so minor that we can really start doing that real tight brake bias and differential adjustments. All right, so that's in. We have the wheelbase front track. That's in. Let's move into the spring rates. The spring installation ratios. And this is actually really simple too. So we're going to go into the suspension tab, and we're looking at the pitch and roll gradient here. So we're using the pitch and roll gradient to tell us what the installation ratios are. So what you want to do is you want to draw a line from one end of this data. I mean, you might, when you boot in, it might look like something like this. You just have to manipulate the graph a little bit, and you want to get a nice tight line that you can visualize here, and then cross-reference this with the 0 on the pitch degrees and the longitudinal acceleration. So 0, 0, and this is this is the aim point right here, this cross between the two zeros. And simply put, we go into the front installation ratio and we start changing changing the parameters. And you see how it made a minor change there. Let's try it again. Let's do 8.8. And then we're getting really warm. Let's try it again. Let's do 0.75. I don't want to overshoot too much. And it looks like it crosses right through the 0, 0 line, and that's all there is to it. Now when we look at the other data like lateral stiffness distribution, we can trust that it's proper. When we're looking at the handling tab and the differential, it's proper. Now there's one thing that's going to frustrate you about the game, and that's the damper installation ratios. We do not have that information. So rear left damper IR is 1 and 1. It doesn't matter. Don't worry about that. Some games will have it, some games don't. But for our purposes, AMS2, this will get us 99% of the way there. Any differences would be minor and probably not even noticeable. Now, the other way of getting your car parameters is, depending on what licenses you have within the software itself. If you have the subscription model, you have access to all of the games. If you are a legacy purchaser like I purchased Project Cars 2. AMS2 and Project Cars 2 have they have similar backgrounds. So what you would do is you would go up into this, when you boot up RST for the first time, you would boot up in Project Cars 2 mode. If there's any cars that they share in common, like the C9, you can pull that information down from Project Cars 2, write it all down instead of having to do the internet research, and then when you boot up RST again, you load up AMS2, you do a session, and you plug in the information from Project Cars 2 into this data, or I'm sorry, into the parameter screen, and you're good to go. So that's it. That's the how to set car parameters for AMS2. Like I said, it was pretty simple but hard to describe. I hope this helps. In any event, we'll be continuing with the content as normal. The next video is going to be the BMW M6 at Virginia International Raceway. That was quite some fun, I must say. Until then, take care.